Okay, everyone, we just finished assembling the cylinder heads, and there's a few things I want to show you on this that's real important. If you want your engine to live, follow these guidelines, and you will have no problems. But it's real important that you do what I'm going to explain here to make sure that you don't ultimately drop a valve or or even worse. But anyways, when this engine came in, it had these rocker arms on it, and there's no markings on them. Now they're good rocker arms. They look like they're Harlan Sharps, and but there's no markings, so I don't know the ratio of this rocker arm, and I need to know the ratio of this so I can figure out the max lift of my valve. So then I can figure out my installed height of my spring, my valve spring. So it starts with this. So the very first thing I need to do is figure out the ratio, and this is how you do it. So you take the rocker arm and you measure from the center point where the stud would be out to the push rod, and you would write that number down, and then from the center point of the, say, the trunnion out to the center of the roller where it would roll on the tip of the valve. Once you have those numbers, which I have these numbers, which was these, then you take the Y divided by the X, and you're going to get the ratio, which this rocker ended up being a 1.7 rocker arm ratio. Okay, so now once I got that number, I had to come over here and I had to figure out what was going to be my max lift of my valve. And to do that, you need to know the rocker ratio, and you also need to know the lobe lift of your camshaft. Now this number here you can get off the cam card, and it's usually on there, but if it isn't on there, it's an easy way to check it. You can take the measurement of your base circle subtracted by the overall diameter with the top of the lobe to the bottom of the base circle, and you subtract the base circle from that number, and that will give you the lobe lift, or sometimes called the cam lift. Okay, so now we need to know the max valve lift when it's in the engine and it's all operating. So what we would do is we would take the lobe lift, multiply it by the rocker ratio, which is 1.7, and that's going to give me the max valve lift. So lobe lift times rocker ratio equals max valve lift, 578. Okay, now that's how much the valve is opening. Now I'm gonna stop and I'm gonna go over to the cylinder head. I'm gonna show you one reason we need to know that number right away. And come back over here to the cylinder head. I already have these set up, but I took the spring back off to show you this. And what we need to know is when we need to know the max valve lift, because we need to measure the distance from the bottom of this retainer to the top of the seal. And the reason is, if this is too close and then the engine's all assembled and you go to start the engine, this is going to bottom out there, and you can break a valve off, or bust the valve guide. I mean, it's going to do damage for sure, and you're going to wreck the engine. So basically what you would do is you would just put the retainer on there with the keepers and hold it with your finger and just take your calipers and measure that. And I'm around 690 thou. So if this was a 600 lift cam, I'd have 90 thou clearance there, which is way enough. Like 60 thou would be good. I'd try to say 50, 60, something like that. So you just measure this, and if you have a problem, like we actually did, we had a problem on these intakes, and I actually had Charles machine these, and I'll insert a video of him doing that. He used this tool here. Howard's Cams makes this tool, and what you would do, if I could take this off, yep. What you would do, this would be off of there, valve out, and you would need to cut this valve guide down. And what this does, this shaft here fits inside the valve guide there, and these cutters cut the diameter of that valve guide down, and also it cuts at the top here, and it cuts the height of it down as well. So I'll insert a video of that, and then we make like a little hockey puck for a stop, and we do that to make them all equal. And we can do all this by hand. We can do this on the mill if we wanted to, but the way we're going to show you, we can do it real quick with just a hand drill, and you can do this at home. But so that's that.
All right, so all set to start machining this. So I just put a little WD-40 on here, and on here just to keep everything cool, lubed up. And here we go. And just like that, it is now machined.
Now that we checked that and we got that figured out, and if we have to machine if necessary, we go ahead and do that. After the valve job is done and we go to assemble these heads, it's real critical to get the spring installed right. If you don't get the spring installed right, you could drop a valve too and it would just wreck your engine. Any of you guys know, if you've ever seen an engine with a drop valve, it just does major damage. So you definitely don't want to do that. So first thing we need to know, which we already figured out, we need to know the rocker ratio, and then ultimately figure out the max valve lift. And what we're concerned about when we install these in here is coil bind. When this spring is compressed, when it has max lift, we need to know the dimension between this coil and this coil. If these coils touch, that's bad. If these touch, that means the valve is binding and you're trying to force it open with the cam, and you're going to drop a valve for sure if you get coil bind. So the manufacturer always gives you that dimension. When you figure out what spring rate you need, and you can call your manufacturer that you like to use, they can tell you what spring rate, and for your cam and things like that. That's a whole nother video that we can do another day. But right now, I just want to show you how to install these springs. So anyways, so this spring here, we'll go back over to the whiteboard. This spring here, the coil bind that the manufacturer gave me was 1 inch and 50 thou. Okay. Now what we need to figure out is the total installed height of this. So what we do is we take the coil bind and we're going to put a safety margin in there. What we want when at max valve lift, the gap between these coils so they don't touch. And that number is 75 thousandths. Use that 75 thousandths, you're not going to go wrong. So what we do is we take the coil bind number, we add in the safety margin, and then we add in the valve lift that we had figured out, and that's going to give us the installed height of this spring. 1 inch 703 is what we're going to install this height at. And I'll show you that in a minute. But one thing I want to talk about that's very important on a performance engine is this spring. Actually, the manufacturer gave me installed height of this spring. And the installed height for the spring that they gave me was 1 inch 750 thou. Now, if I would install it at 1 inch 750 thousandths, it would absolutely work, but there's a small problem with that. And it has to do with performance. So these springs, when they're in their engine and they're being compressed up and down, they actually flutter. If you had a camera in the engine watching these, they will actually generate harmonics between the opening and closing of this spring. So in a performance engine, what you're going to want to do is you're going to want to have when you have max height, when you're squeezing this the most, you want to have these coils closest to the coil bind with your safety margin as possible. If I was to install this at, say, the 1750, I would have not the 75 safety margin that I would want. I would have like 148 or something like that. The problem with that is the more that you have of this safety margin, the more harmonics you're going to have on this spring. And what would happen if you were run this on the dyno, you would actually have some valve float because of that. The safety margin is too big. Basically, what you're trying to do is you're trying to get that close to the coil bind, and that basically dampens the harmonics of the spring, and you're going to have more performance if you shim up your spring. That's why I like to work backwards. I figure out my coil bind, I put in my safety margin, I add in my lift, and that gives me my installed height. So my installed height is basically 1703, which is 50 thousandths more than what they wanted the spring for. So for a performance engine, 100% do it this way, and that way you're not going to have as much harmonics on your spring. And then when you're dynoing your engine or running your engine, what would happen is you would see basically your RPMs would fall off. It would be like valve float. And if you ever seen valve float on the dyno, your RPMs would be going up good, and then it would just fall off. And then you'd be shaking your head and you'd be like, what just happened? And you'd be chasing your tail trying to figure things out. But 90% of the time, if it's a new spring and it's doing that, that's the reason. because you have too much safety margin or the coils are too far apart when you're at max lift, and it creates harmonics. So just a tech tip for you guys. Follow that and you'll have no problems. Guys that probably encountered that, they'll know what I'm talking about. So now that I have this number here, this 1703, and we'll go back to the head and I'll show you how we set that up. So what we would do, and I already have this figured out, this is a micrometer to measure for your valve height, your valve spring height. So you put the valve in there, and I have, this is inside diameter locator for the spring. It locates on the inside, and sometimes they have outside diameter ones. So you always need to have this. And then under that, I have the shims, which I already figured out. So what you would do is you put the shims on there, and you put on there, take a guess of what you think you might need, and just, put your micrometer on there. And you put your keepers on there. Get it in there right. And adjust it out. Right there, 1705. It's like 10706. And what I do, I write it right here right on the ledge here where the rockers are. So after I do it, I write it down, and I know that one's done, and I can refer back to my notes. And it says double checking my work, like I said before. So if you look back on the whiteboard, my installed height was 1703. 1703. Come back over here. If you look, this thing is 1 inch, and it shows the 7, and then I'm 1/9 past, so I'm like 1705, 1706. So that's good. I'm only a few thou away, and your shims come in 15, 30, and 60. So you're gonna fall in between the smallest one. So if you're in between the 15 thou shim, close to your number, you're good to go. And once you have that done, then you're ready to put it together. Take it apart. Make sure you put your seal on. I got one of these tools here that you can put on here. You give it a tap, seat it on there. Then you take your spring compressor, compress that down, put your keepers in, and then you're done. So that's it. Follow those guidelines. It doesn't matter what size cam. You can figure out, it doesn't matter what size rocker ratio. This applies to a race engine, performance street engine, all engines. I mean, if you go by this, your engine's going to run good. You will have no problems. And again, the worst thing you could have, other than kicking a rod out, is dropping a valve. It just destroys engines. But okay, so that's it for this part. So now we're ready to install the heads on the engine, and after that, we'll start putting the valve train on, and we'll show you guys that part next. Okay, we're back here at the engine, and I just got done putting the cylinder heads on. As you seen earlier, that we have the heads were all together. And what I wanted to do, I should have did a video before I put the head on, because I wanted to show you something that's very important. This is a Gen 4 GM block, okay? And there's 2 versions of this block, and it has to do with the coolant passages. You have to be careful about this, because when you put your cylinder head on, you got to make sure you have the right gasket for the block that you're using. And the differences are at the right above the bottom row bolt here on the deck surface. You'll either have 3 coolant holes about that big in a row, or you'll have none, or you'll just have one at the end. The one on the end, and the one on the end is a separate gasket, and the one with all the holes is its own gasket also. So you can't mix those up. If you mix those up, you're going to be blocking. You could block coolant holes, and you're going to have a coolant issue. You're going to have overheating problem. So it's critical that you make sure you get the right gasket for the block that you have, and it's just something that you guys are going to have to pay attention to when you're building a big block Chevy. So that's that. And then the next thing is, when I put the heads on, I I mentioned before that these GM blocks, the bolt holes go through into the coolant passage. So in saying that, what we would do, if this is a main bolt, but we'll simulate it like it's a head bolt. What I would do is I would put a ARP thread lube right under the head of the bolt, and then I would take the Right Stuff sealer and put it on the threads, wipe it with your finger real good so it's down in the threads, and then put your bolt in. And you got to do that on every single one. So ARP lube underneath the head, put your washer on there, and I usually just turn the washer, and then I put the sealer on the threads, put the bolts in, then run them down. Then you torque them three steps. Then after that, the next thing I want to talk about is these rocker studs. Now this is very important on this. On a GM iron head, 2 of the rocker studs go in an intake port, okay? So you got to make sure you get sealer on the threads that for the rocker stud that goes into the intake port. If it's a GM aluminum head or aftermarket head, most likely there's going to be 1 in each port that's going to have a bolt. And you just got to watch out for that, because what will happen is you might put it together, start the engines running good, and then all of a sudden it starts burning oil, and you might think it's a pinched ring or valve guide, and you're going to be worried like, oh man, you know what happened on my motor? I got to rebuild it. And it can be as simple as the threads not being sealed on that, and that's a pretty common thing. You could use red Loctite to put on there, but I just put this stuff on there, man. You can't go wrong. So pay attention when you guys are putting it on, because you could think the motor's burning oil and there's something wrong with the motor mechanically, and there's nothing wrong with it. It's just going to be oil, you know, seeping through those threads, getting in the intake, and it gets in the combustion chamber, and the next you know, you're burning oil. So that's that. Okay, so the next thing I want to talk about is I'm getting ready to put the valve train on right now. And before, I'm going to do an actual video on just that portion, but I'm putting the lifters in right now, and what I want to show you is you got to be real careful with the big block Chevy when you put these lifters in. If you're using a roller lifter like this, they'll have an arrow on the tie bar, and the arrow always points up. You got to be careful, because if you turn the lifter around like that way, now the arrow can be pointing down, and it would go in, but it will bind up if you do it like that way. I actually had an engine come in here that one of these were upside down, and the customer's engine broke a lifter, and it ended up scarring up the lifter bores, and it did some damage, but we were able to fix it. But you gotta pay attention. So make sure all your arrows are up. And then another thing is, when you buy lifters, buy good lifters. I mean, even if you're doing a budget build, big block, buy good lifters, because if a lifter breaks, you're gonna wreck your engine. I mean, this is like engine building 101, man. You, don't cheap out on the lifters. We're using Johnson lifters here. There's a good quality lifter. Isky sells them, and they're made in the USA. And this is one of the main lifters that I like to use. And if you're doing a race engine, you know, I like using BAM lifters, or I'll use Isky lifters. You know, sometimes we use Jessel. But these Johnson lifters, and these are hydraulic, by the way, these are awesome. These work good. And so what I normally do is I'll take the high pressure lube when I'm putting these lifters in, and I'll use the high pressure lube. I like to do that just because this is what I've always done, and it works good. Just wipe it on there like that. Make sure your arrow's up, and then put the lifter in. Obviously, we did all the machining, and we honed lifter bores, and they're nice and snug. So that's that. So now what I'm getting ready to do is I'm going to put the valve train on, and I'm going to show you how to adjust these lifters. Real easy method. And this is why I have the intake off right now, because what we're going to do is we're going to look and see where the base circle is, but I'll explain all that in the next part of the video. And also too, you can see I got the intake gaskets on, and we're getting ready to port match this intake and port this intake, and Charles is going to do that. but I have a video of that already. So if you guys are interested in seeing how the intake manifolds are port matched, go on, look farther back in my videos, and I got a video just on that on a big block Chevy. And so I'm not going to cover too much of that right here. But what I will say is when these heads came in, these heads were ported already. So whoever ported these heads had a gasket they used, or I don't know what they used, but I couldn't really find a gasket to match that up. So what you would do in a situation like that is just take a smaller gasket, which is what I did. And I just took an oval port gasket, which is smaller, and then I glued it to the head, and then I cut it open to match these ports, and then you can use these as your template to match up to your intake and port match it that way. But so anyways, that's it for this part. Stay tuned for the valve train. That's coming up next. Okay, so we're getting ready to do the valves in this, put the valve train on this engine. But before I go into detail on how to do that, I want to explain something real quick with you about these lifters. These are hydraulic lifters, and a hydraulic lifter has a plunger inside. And the whole goal is when we adjust this, we want the plunger to be centered in the lifter. Now, the manufacturer gives you that dimension, and on these particular lifters, the center of this plunger would be from 0 down between 30 and 40 thousandths, and that's what we're going to shoot for. So just remember it, 30 to 40 thou, and now I'm going to go into detail in how to get that centered in the lifter body. Okay, so now we're putting the valve train on the engine, and as I said, I want to do a video here and explain to you quick, easy way to do it, accurate, and it will never fail if you do it this way. And as I mentioned, I left the intake off. I left it off for a reason, because what I like to do is I like to be able to look down inside the engine at the base circle of the cam. And I look down in there, and I can see when it's on the base circle, and I can see when the lobe is up. So what I'll do is I'll just crank the engine over until the lobe is 180 degrees from the lifter. And I'm going to do this one right now. Okay. But before I do that, I want to show you something. How I'll go about doing this. We'll go over here to the board. Okay, so this is the stud. The stud on the engine where the rocker goes, rocker stud. So the threads are 7/16 20 threads on that stud, okay? And that means there are 20 threads per inch. So if you do the math, take 1 inch divided by 20, one full turn will be 50 thousandths. So 50 thousandths equals one full turn, okay? But my plunger on my lifter, to get it centered, is what we're shooting for, is between 30 and 40 thousandths. So if you do the math again, so if 50 thousandths is one turn, therefore 3/4 of a turn will be 37.5 thousandths. So what we're going to do here, we're going to go back over here, and when we adjust this, we're going to go 3/4 of a turn. So I already have it on its base circle, which is right here. So if this cam was turned around and you had your lifter here and this lobe was down, that would be 0 lash. Your lifter would be right on there. So when I'm looking down in the engine, this lobe is pointing downward and my lifter is up here. So that's what I just did. Now we'll take this high pressure lube. We'll put a little bit on the push rod. Put it in there. Another little tech tip, on a big block Chevy, the longest push rod is always the exhaust. So if you're reaching for your push rods, it's an easy way to know that. And I'll take a little bit of pressure lube, and I always put it in the cup of the lifter. Now, I'll take my lifter, or my rocker arm, sorry. I'll tighten this down, making sure my my lock nut is not bottoming out first. We'll back that off. And we'll turn the adjuster nut just till the push rod, I'm turning the push rod, I can feel it snug. You can see it's right there, stops. That's 0 lash, okay? So now what we're gonna do, because we wanna turn this nut 3/4 of a turn, and we wanna be accurate about that to get our plunger centered, what we'll do is we'll make a mark here with the silver marker at 12 o'clock on this nut. Okay. Now, what I like to do is I will turn this nut about, I would say about 5/8 of a turn till it's about right there. And I'm going to show you why here in a minute. Turn it about just about there, not 3/4 of a turn yet. Then I'm going to jam this nut down, the lock nut. I'm going to give that a pull, lock. I'm still only 5/8, but I want to be 3/4 of a turn. So when I lock this in like that, then I give both a turn. A little bit more. Boom. 3/4. I went 3/4 of an inch, or 3/4 of a turn. And what that did was that put my plunger between 30 and 40. It actually put it at 37.5, which is right between 30 and 40. That means my hydraulic lifter, the plunger, is dead center in there. And that's what you're shooting for. Now, it's easy to do when you got the intake off, and I can look down there and I can do it real fast. I don't even have to think about, if one rocker is up, one's down. But if the intake is on and you need to figure out if you're on your base circle, you can do it the same way as if you would if it was a mechanical cam. If it was like a solid lifter cam. And basically, I'll explain it real quick, but I do have a video of that. If you go on my videos and you look at the 588 nitrous engine, I show you how to do this in detail. But basically what you would do, if you're doing it with the intake on and you wanted to get each rocker on the base circle, you would always do the exhaust first. And so if you're going to do the exhaust first, you got to be looking at the intake valve. So what you would do, you would just crank the engine around. Keep going until this one here goes down, comes back up, and just closes. When the intake valve just closes, your exhaust valve is on the base circle. Okay, then you can adjust this one. Then if you want to go to do this one, and this one be on the base circle, what you would do is just keep cranking this until your exhaust opens, like that, and now your intake is on the base circle. So that's how you would do it. And then you would go back and then you would mark your rocker. You would turn your nut to your push rod, just stop turning, mark it, turn it 3/4 of a turn, and you're done. But again, if you guys want to see how in detail how I do this again, I got a video, the 588 nitrous engine, and you can see how we did that. So after I get all these on, the next thing is going to be putting the intake on. We're going to scribe it, and then I'll have Charles, he's going to port match it, and then we'll put that on. And then after that, the next video will be how to drop the distributor in. And that'll be quick and easy way to do it. And so stay tuned for that. Okay, so we just got the valve train on, and I showed you how we adjusted that, how we went about doing that. Now we're getting ready to put the intake manifold on. I'm just going to show you a couple little tech tips, what I do. If I have the time, what I'll do is I'll actually glue the gasket on to the cylinder head first, and I'll let it dry overnight. But what I'll do is I'll put the gasket on here, and I'll glue it down, and then I'll take the intake off. And then if there's any sealer that comes into the port, I can wipe it out. I can clean it out. And then when I put the intake on, I'll just be real careful. A small, very small bead around the port, so no sealer goes in there. That's if you have the time to do that. Sometimes we got to put the intake on right away, and you just got to be real careful to do that. But so we're getting ready to glue this on, and I want to show you Charles port matched the intake. He did a real nice job. Come over and take a look. So he port matched it to this gasket that we made from an oval port gasket, and then we cut it out, and then he ported it just a hair smaller than the gasket itself. So you have no step when you have airflow. So the intake port is a little bit smaller than on the head, and then you get better flow that way. If you have a dead edge and the air is hitting the dead edge, that's obviously no good. So we're getting ready to put the intake on, but before I'm doing that, I actually put oil in the engine. And another couple points that I wanted to mention, we just poured it right down here in the lifter valley here, but you want to use a good oil. I mean, that goes without saying. A good oil and a good filter. But what I like to use on a street engine like that, I'll start off, we'll use the Valvoline VR1 because it has zinc in it. Even though this is a roller cam, it's just good, in my opinion, to run with zinc, break it in. And I run this oil anyways. But we'll run it on the dyno. We'll break it in with the 1030. And then, you know, with summertime, we'll switch it to 50 weight oil. And what we always do, our procedure here is when we run it on the dyno, before we take it off the dyno, we'll pull the filter off. We'll cut the filter open. We'll make sure there's nothing in it, and then we'll switch the oil, put a new filter on it, and we'll give it to the customer then that way. But so yeah, so what we're gonna do, we're gonna get ready to put the intake on. After I get the intake on, I'm gonna put the distributor in. I'm gonna show you how we do it, and just a little tech tip on that as well. So stay tuned for that. That's coming up next. Okay, so we got the intake finished up. It's all bolted down, sealed up. A few things I want to mention about the intake putting on that I didn't mention when I talked about it before was just you got to make sure that you seal your bolts. Seal all your bolts because these threads go right into where the lifter valley is, and oil will come out. And plus, if you got an engine that's needs to be sealed for vacuum, you need to seal that if you got a vacuum pump on there. But so that's that. Another good little tip that I didn't mention that I want to tell you guys what I like to do if you guys are putting the gaskets on. What I like to do is take some tape, and I actually tape the gaskets after I seal them, and I put the intake on. I'll tape with just masking tape. I'll tape like 3 spots on top of the gaskets, because what happens is when you go to bolt the intake down, because this is on an angle, it wants to push your gaskets down. And you might not even know it's pushed down. And then your gaskets will be inside, you know, hanging in the port. So put the tape on there, bolt it all down, and that keeps the gasket from moving down. And then after it's all bolted down, you just pull your tape off. Just a little tech tip that I've learned over the years, you know, that I do. Another thing I didn't mention before, I mentioned use good oil, but also use very good oil filters. Don't cheap out on oil filters. What we like to use, we use a Wix Racing, or you can use a Napa Gold, or you know, K&N. Them are all good filters. I wouldn't use anything else really. You know, filtering your oil is important. Another thing is we're getting ready to prime the engine. That's what I'm getting ready to do before we drop the distributor, and we're going to do a video on dropping the distributor. But right now, we're going to prime this, and the reason why this is so tall, you're probably wondering, because I modified this for tunnel ram intake. So when it's got a tunnel ram, that makes it easier to get the drill on there. But anyways, we're getting ready to prime it, and what you're going to want to do is put you a gauge on there so you can see, make sure you got good pressure when you're turning it. And the key thing is when you're priming your engine, you have to make sure that every single rocker hit gets oil to it. Don't just assume that it has oil because a couple of them have oil. I would keep turning that drill until it squirts out every single one. Especially on a race engine with real strong spring pressure, because if you don't have oil to your tips of your rockers, you'll burn the tip of the rocker like almost instantly. You know, if you got something like, you know, 1,000 pounds open pressure, something like that, you know, like on you know, nitrous engine or, you know, boosted engine springs, you'll burn the push rod up instantly. So make sure that's just good practice. Even on this, you know, this street engine, you know, doesn't have that kind of spring pressure, but I just do it anyways. So what I'll do is I'll just hook the gauge up and I'll crank it, and then I'll just, you know, you can see I got 70 and it's already squirting out right there. Now I'll go until it comes out of every single one. But what I'm going to do is I'm going to put the valve covers on so I don't make a mess. I'm going to crank it, and I'm going to take them back off, and I'm going to verify that oil is coming out of every hole of the rocker arm. Another thing, before I drop the distributor, and I'm going to show you how to do that, I want to mention that I didn't mention is that this has a roller camshaft, and if you run a roller camshaft, you need to change your gear on your distributor to either a melanized or a bronze distributor gear. you can't use a steel gear because then it will actually the two similar metals they'll eat up, and then you'll have the gears will eat up, and you'll have shavings in your motor. So it's critical that you switch that to a melanized or to a bronze. Now, how to tell if you got a melanized gear? They got these little speckles on here. It's like a cast iron gear, but it's got speckles, and that's how you'll know that it's melanized gear. I already switched it on this one. And then the next thing I'm going to do is I noticed that this distributor, this was the distributor that came in with this engine. It has really stiff springs on here. I'm going to end up changing these springs and the bushings for a different curve because this would take, the timing wouldn't come until way late with this. So I'll do a video on that, but I just want to mention that right now. But anyways, gear, I would change your springs if needed before you drop it in, and then stay tuned. We're going to do a video on dropping the distributor. Okay, guys, I'm getting ready to drop the distributor in, but there's a few things I want to do to the distributor before I put it in, and I want to show you these things. I want to change the way this advance is going to come in with this engine, and we're going to be using this MSD distributor. And this is a nice distributor. One thing nice about it, it allows you to change the bushings on this and to change these springs, and that allows you to dictate the mechanical advance on this distributor. Okay. Now, on a street engine, we want the mechanical advance because we want the timing to come in at a certain rate that the engine wants. Okay. Now, this distributor has these bushings in here, and it's underneath this screw. Okay. And these are what the bushings look like. And each bushing are different colors, and the colors dictate different diameters. And these color bushings dictate how many degrees that this mechanical advance will open up to, that it will allow me to gain advance. Okay, so in saying that, this distributor, when I checked it, it had the black one in there. It had 18. Okay, in my opinion, I don't think that's going to be enough advance timing. So what I'm going to do is what I did already. I actually switched it to the blue one, which is 21. Okay. Now the reason why I'm switching it to the 21 is this. Based on my experience, I've built these motors many times. This motor is probably going to want about 38 degrees of timing. I'm guessing right in there. It might want 39. It may want 40, but I'm going to start off at 38. We're going to run it on the dyno. We're going to see what amount of timing that the engine likes and to make peak horsepower. Okay. Once you get over the certain timing, when you get too much timing, then your horsepower will fall off. So that's how we're going to know our happy medium where the engine's going to like timing. So we'll run the engine. We'll figure that out. But based on that number, where my total timing is, which I think it'll be around 38, that's why I selected the 21 degrees bushing. So what will happen when this thing runs, this thing will open up and it will allow me to go the 21 degrees. And therefore, if I want my total timing to be at 38, that means my base timing or my initial timing will be at 17. Okay. Now 17 might sound like a lot, which it probably would be, but what's nice about this distributor requires an MSD box, and the one that we're going to be using on the dyno is a digital box, and it has 10 degrees start retard on it. So we'll program it to have 10 degrees start retard. So therefore, when we're cranking the engine, it will actually be at 7 degrees. The engine will be at 7 degrees trying to start, which will start easily at 7. As soon as the engine fires off, that 10 degrees will go away, and then it will be at 17. The engine will be idling basically at 17 degrees. Then we have these springs here. These springs dictate how fast these weights are going to go open. Okay. Now, this had the real stiff springs, which I took off. Because why I don't want that is with these stiff springs, you would have to crank the engine up. You get almost a max RPM before these springs would open up to allow to get to max timing, which means it will probably be at the end of your RPM range, which we don't want that. We want it to come in earlier. Okay. So we dictate that with these springs. So I started with the softest spring, and I'm going to try it there, and then we'll see how the engine likes it and responds. Now, if I feel like it needs to slow down a little bit, I can just take one of the silvers off, and I can put the blue one on, and the blue one is a stiffer spring, so I can have one light one and one stiffer, and then that will slow it down. And if I wanted to go another step, I could take the light spring off and put two mid-range springs. And then, and then ultimately, if you wanted to take them off, you could put these on, but you probably would never need these. Okay. Now, the key to all this is every engine's different, but you want to run as much timing as the engine will allow and get the timing in as quick as possible without detonating the engine. If you can get the timing in quick and get all your timing in that the engine likes without detonating, it's gonna be real snappy throttle response. It's gonna run good. It's gonna make the most horsepower, and through the RPM range too. So that's why I really like to focus on this, because this is important. This is the tuning of the engine of this, along with the jetting of the carburetor, which we'll do on the dyno, is important. And this is what I like to do. I mean, on all my engines, I mean, you could take an engine and just fine tune this and fine tune the carburetor, and you could take an engine that's just kind of lazy, mediocre, and just, man, make that thing wake up and be real snappy. And I can show you an example of that. I did a short video of a 68 Chevelle, orange Chevelle that we built the engine. And I did a video, I did a burnout in it, but showing my customer how much throttle response it had. Basically, from a dead stop, I just whacked the throttle and this thing just went right up in smoke. I just instant RPM, no stumble, no cough, no nothing like that. And that is totally due to getting your timing curve right, your max timing, and obviously the jetting of the carburetor. But so anyways, guys, this is important. That's why I wanted to show you that. Again, every engine is different. I'm going to start with this, but by the end of it all, I might change a bushing, I might change a spring. I just don't know yet. But based on my experience, this is a good starting point, and maybe it will stay just like this too. So what I'm going to do next is I'm going to put the rotor on here, and I'm going to go over to the engine, and then I'm going to show you my procedure on how I drop the distributor. And I know a lot of guys probably know how to do this, but I'm going to show you a couple of tech tips that I like to do. So that's coming up next. Okay, guys, now we're getting ready to drop the distributor in here. And I just, again, I know some of you guys probably know how to do this, but I'm just going to show you my way and a couple of tips on this, which really works out good. Okay, so what we're going to do is we're going to rotate this engine so the number one cylinder is on the compression stroke. And the way I'm going to do is I'm just going to crank this over. I got all the spark plugs out so it's easy to turn. And I'm going to stick my finger in the hole where the number one cylinder is. And I'm going to rotate the engine until you hear the compression come out of the hole. And then I know I'm coming up on my compression stroke on number one. And that's where you want to set the distributor, on number one on the compression stroke. Okay, but the little trick here that I want to tell you about is earlier when I was setting up the distributor and I was talking about the total timing that I thought this engine was going to need, I said 38 degrees. Okay, so back in the day when we were taught to put it on zero, number one, compression stroke, drop the distributor. Okay, but we're gonna modify that a little bit, and the reason why we're gonna do that is this. So I'm gonna bring it around on the compression stroke. Instead of going all the way to zero, I'm gonna come up short. I'm gonna come up 38 degrees before top dead center. Okay, and the reason why I want to do that is because I'm going to drop the distributor in how I want my distributor to be indexed when this engine is total timed, which will be at 38. I don't want to really have to move the distributor much. And the reasoning behind that is I drop the distributor in and I make my spark plug wires and everything looks nice and neat and it looks great. And then I go put the engine on dyno, or you put your engine in your car and you go to time it, and now you got to turn the distributor. Now what's going to happen? Your wires are going to be all messed up. It's going to be bunched up on one side, and it's going to be tight on the other side, and it ain't going to look like the way you wanted it to work. Okay, so that's a little tech tip for you. As you guys can see, I'm pretty anal about how I want my engines to look. So the spark plug wires are no different. Okay, so what I'm going to do is I'm going to rotate it around. You'll hear the compression come up. I'll stop it at 38. I'll show you how I'm going to drop the distributor, and then we'll lock it down. Now, what I'm going to do is I'm going to take it one step further, and you guys can do this too. I'll drop the distributor at 38. Instead of me making the wires right now, I actually have an old set of wires that I run on the dyno. They're not old, but they're longer. And I'll run the engine with that. I'll actually time the engine, and I'll get it exactly to 38. I'll verify, and then I'll make my spark plug wires. because by that time the distributor will be locked down. It will be at the timing that it needs. I'll never have to touch it again. And then I can reroute my wires, and I will make these wires custom. Each one will be cut to length and be nice, neat in these little wire looms. And then you won't run into that situation. Like I said, you have to turn the distributor to time it, and then your wires will get all funky on you. Okay. So that's what we're going to do here, and that's what I'm going to do. And that's just a nice little tech tip. If you like your engines to look nice, detailed out, and your wires nice and neat, things like that, you know, do your wires after you time the engine. Okay, if you have some wires that you can run the engine with. Otherwise, if you need to make your wires prior, then do it just like I'm saying. Put it to the degrees that you think it's going to be at. Make your wires, and then you're going to have to turn the distributor minimum amount. I mean, very, very little. Okay. So what I'm going to do here, I'm going to rotate this around. Put my finger in the hole. Right now, it's sucking my finger in. It's not compression yet. All right, it's coming up, but still no compression. This means I'm on the intake stroke. Keep coming around. Come around again. Now I'm going to come up on the compression stroke. Now you got to start listening. There it is. Compression. So now what I want to do, instead of going all the way to 0, I'm going to go to 38. Right there. 40. There's 2 lines. 38. Now what I'm going to do, now I'm going to drop my distributor in. A couple little tricks here. First thing I like to do, before I even come over by the engine, I'll figure out where I want my number 1. And on this cap, I like my number 1 to be right here. You can put it anywhere you want. But the reason why I like it here is because the wires lay out the best. This when you put number 1 right here. And then you go around the firing order. And when I get this done and I do the wires, I'm going to show you guys that it's going to be real nice and neat the way the wires lay out if you put the number 1 right here. And this is going to be just like that. Okay. So in saying that, I put the cap on the distributor. I know I want that one number 1, so I write number 1 on there. I'm just showing that for demonstration purposes. And then I mark a black line on the body. Okay. So now, ultimately, this is how I want my distributor to be in there, just like that. And I want these screws to be like straight across from one another. Now, to make that happen, what we have to check is we got to lift this up and we got to see where the oil pump rod is. On the bottom of this is the little groove there, the little tang that engages the oil pump. Okay. And then down inside the engine is the matching part. The oil pump rod is down there. And what we have to do is we have to get them close to matching so the distributor will fall in. If you don't have that right, along with the meshing the gears, and when you go to drop this in, the rotor won't be in the right area that you want it. So what I like to do is I'll put this like this, and I'll simulate like I'm dropping it in there. I want these screws this way, and then I'll look up like this. Okay, so right now that little thing is going like this. Okay, what I'm gonna do is I'm gonna get a screwdriver and I'm gonna go down there and I'm gonna turn that oil pump rod and I'm gonna turn it in line just like it would be, but actually I'm gonna back it up. I'm gonna back it up maybe like a 16th to an 1/8 before that. So instead of being in line, I'm gonna back that rod up and then this thing should fall right in if you do that. So what I'm gonna do is I'm gonna look. Again, it's going that way a little bit, and I'm gonna go look down in there. So if I put it like that, it's in line, but what I'm gonna do is I'm gonna back it up just a hair. Right there. Now, take this off. Also too, always lube up your gear. I didn't because I lubed up the cam. The cam already has lube all on it, on the gear. So, but if I didn't do that down there, you'd have to do it on here. So don't forget to do that, okay? So now, drop it down in here. And again, we want our number 1 to be right in this area. So I'm going to go down and I'm going to back this up just a hair. I'm going to feel for the for the tooth. So right now, that's it. It's exactly where I want it. See there? Now I'm going to put the cap on. Boom. There you go. My number one is there, and my screws are in line. That's dropped in perfectly. Now I'll lock it down, and then I can either make my wires right now, and they wouldn't be far off, because this is, I put that at 38, which I think the timing is going to be at, and this is going to take minimal movement when I go to time it. But if you want to be absolutely perfect, then you can run your engine with some older wires, time it, then make your new wires after the distributor's already turned. But that's it. We're just about done, man. We're getting ready to put this on the dyno. This is part number 4 in the build series, and this is the end of part 4. And then the next thing is going to be the next one is putting it on the dyno, which will be part 5, which will be the final part in this build series. So when we get on the dyno, we'll start tuning the carburetor, and we'll show you some tech tips on that. So stay tuned. It's coming up next.